Hi, I'm Tucker Hathaway.
Hi, I'm Zach Christopherson.
This is our microcontroller's final project. We are controlling a coffee maker using our microcontroller, incorporating a start, stop, and delay command.
So a little bit about the functionality of the coffee maker. The input can be received from the keypad or from a Bluetooth device. Because the keypad only has an A, B, C, or D on it, there is no S for start time. Therefore, we decided that A will be the start command, B the stop command, and C will be followed by 6 digits representing the delay time that Tucker mentioned. If an A is pressed without any delay time, the coffee maker will begin to brew. If C followed by those 6 digits, that corresponds to the delay time, like I said. If that is inputted, the delay time will be displayed on the LCD, and you can watch that count down to 0. Once that timer expires, the coffee maker will be triggered.
After the coffee maker is triggered, it will remain on for a preset amount of time corresponding to the brew time. For this demonstration, we've set that to 6 minutes and 30 seconds because we found that that was about the amount of time it would take. After that time, it will display done on the LCD and send a done message through Bluetooth. The coffee maker will stay on after that point for another preset amount of time, representing the time that it keeps the coffee warm. We've set that to 1 minute for this demonstration, at which point, after that timer has counted down, the coffee maker will turn off.
This project incorporated a lot of timers and a lot of calculations, but it works well. So now we're going to demonstrate how this project works. So the first thing that I'm going to do is I'm going to click a C followed by 6 digits. So I'm going to do 10 seconds. This corresponds with the delay time. Once that is clicked, it displays on the LCD. Now I can either start it from the keypad or I can start it from my Bluetooth. To demonstrate the Bluetooth, I will send an A for the start command. As you can see, the timer starts. Now I'm going to send a stop command from the keypad, B. As you can see, the timer now stops. Now to demonstrate that it can send time either way, I'll send another delay time of 10 seconds from the Bluetooth. It appears on the LCD, and then I will start it from the keypad. Now, this time represents the delay time like we talked about. Once this delay time reaches 0, you will see the relay and hear the relay click.
You can see after the countdown timed out, the coffee maker turned on, which was signified by the blue light turning on the relay. Then after that, about 6 minutes and 30 seconds, the done message was displayed on the LCD and the buzzer sounded. Then about a minute later, the coffee maker turned off, which you could see by the blue light turning off on the relay. For the technical components of this project, we used the ECE3710 Bluetooth module, which is a very common module used for microcontroller projects. Then we used a 5-volt single-pole, single-throw relay, which was switched on using a transistor. And the buzzer is a simple piezoelectric buzzer. The ECE3710 Bluetooth module communicates with the discovery board using UART. We set up the receive function as an interrupt in order to avoid polling. Initially, we had the one interrupt was supposed to gather all of the characters that were sent, but then we realized that we were stuck in loops because with every character that was sent, a new interrupt was generated. We fixed this by using a global variable as our placement in our buffer. One issue we ran into was if one command was sent through Bluetooth, then only that command could be sent throughout the life of that program, that run of the program. We aren't entirely sure what caused this issue, but we found that in our switch statement that took either A, B, or C, we added a default and put a delay in there. This fixed the issue. We're not entirely sure why, but it worked.
In the original design of this project, we had the keypad as a polling mechanism, meaning that we'd only receive the input by polling. This proved to be a challenge because this meant that we could only use the keypad or the Bluetooth to receive the input and not both together. So to fix this issue, we set the fourth column of the keypad as an interrupt. This was because those are the first command that's going to be sent to the microcontroller, therefore it could be an interrupt. And that fixed it really nicely.
In order to switch the coffee maker, we used our 5-volt relay, but the GPIO pins only source 3 volts, and they can't generate enough current in order to switch the relay either. So we had the GPIO pin connected to a transistor, then the transistor was connected to an external power source, and that transistor is what was used to switch the relay.
Overall, this design went pretty smoothly. We talked about the hangups that we had. The project itself met all of the requirements that we set out to do. It used both Bluetooth and keypad to receive the input. It takes coffee and it makes it. We were able to get accurate timing on the timers, and we were able to complete the design without any problem. Thank you.